Hey everyone, today we're going to take a look at page 50, our trigonometric sum and difference identities. So this first part says, consider that we have the expression sine of 45 plus 60. And we want to see if that would be equivalent to if we added these together. So if you took 45 and 60 and added together, you'd get sine of 105. So the question is, are these two things equivalent to each other? And how could we make them equivalent to each other? So you can see down here they said, what happens if you take the sine of 105 versus what happens if you take the sine of 45 plus the sine of 60? Well, we know the sine of 105, if I do this as a decimal, take the sine of 105, I did this in my calculator so you can't really see it, but I got 0.9659. And if I were to go over here and do the same thing and take the sine of 45, I would get 0.7071. I know that those are on the unit circle, but for the sake of adding these together, I'm doing it just in the calculator. The sine of 60 gave me 0.8660, so 0.866. Well, if I add those two things together, I end up getting 1.573. So the point being that if you take the sine of 105 and then take the sine of 45 plus the sine of 60, they do not come out to the same thing. It's important to know that that property exists, just like if we were doing something like distributing, right? If you have a squared, for example, if you had 3 plus 4 squared, it's not squared. It's not squared. Go away. There we go. 3 plus 4 squared versus 3 squared plus 4 squared, we know we're going to get different answers. This would come out to 7 squared, which is 49. Whereas this would come out to 9 plus 16, which is 25. So we can see that they don't do the same thing. So that property, that same idea applies here. So instead, we have this formula that we're going to use. And I'm actually going to skip past this and just jump down to here. So the first formula that we have to know is the sine, sum, and difference identities. So for sine, if we want to find the sum of two angles, A plus B, what we do is we take the sine of A and the cosine of B, keep whatever sign we have. So in this case, we're doing sum, so we're keeping addition. And then we switch it and do the cosine of A, sine of B. So here we did sine, cosine. Over here, we're just reversing it and doing cosine, sine. Likewise, if you want to do the difference, notice that this minus sign carries over here, but everything else is the same. The only difference is that this plus and minus change. If you're doing addition, we use addition. If we're doing subtraction, we use subtraction. So coming in, let's actually set this up. It says find the exact value of sine of 15 using two angles from the unit circle whose difference is 15. In other words, we take sine of 15, and we want to rewrite this as sine of two numbers that would subtract to give us 15. So if I think about the unit circle, what numbers exist on the unit circle? Well, we know that 30, 45, 60, and 90 is what's in that first quadrant. So from that, I could take 45 and subtract 30, and that would be the same thing as 15. Again, noting from the example at the beginning, you can't just take the sine of 45 minus the sine of 30 and get the answer. It doesn't work that way. But we can use our formula that we just talked about. The sine of A minus B is equal to sine of A cosine of B, keep the sign minus cosine of A, sine of B. So we're literally just going to set that equation up. So let me just move this over. I took up a little bit of space here. Oh no. There we go. All right. So what we're going to do is we're going to take that formula. So I've got 45 first. So I'm going to take the sine of 45, and then we do the cosine of 30. And then we're going to use minus since it was a minus problem. And now we're going to switch it and we're going to do the cosine of 45 and the sine of 30. And so those are on the unit circle, so we could solve that from our unit circle, and we are going to do that. So we know that the sine of 45 is square root of 2 over 2. And my cosine of 30 is going to be square root of 3 over 2. Bring our minus in. And again, cosine of 45, and we know that anytime we do 45, we got square root of 2 over 2. And our sine of 30 is going to be 1/2. So now I can take these things and multiply them together. Remember, when we're multiplying, you multiply the numerator, multiply the denominator, and then we don't have to really do anything with it. If you're multiplying square roots, though, you're going to multiply the numbers underneath the square root. So for example, in this first one, it's square root of 2 times the square root of 3. That's going to become square root of 6. And then on the bottom, 2 times 2 is 4. Got my minus sign. Square root of 2 times 1 is square root of 2. And 2 times 2 is 4. And since those both have the same denominator of 4, I can rewrite it with the 4 as the denominator and put the square root of square root of 6 minus square root of 2 together. And that is what our sine of 15 would be equal to. So in the next one, it says, find the exact value of sine of 285 using two angles whose sum is 285 on the unit circle. So we're getting a little bit more complicated now. We got to think about numbers on the unit circle that would add together to get 285. So the problem is that the first thing that kind of jumps out to me is I'm like, hey, I know 270 is the bottom of the unit circle. But if you take 270, you're going to have 270 plus 15. That one's not on the unit circle. The 270 is, but the 15's not. So we're not going to be able to use that. So you've got to keep thinking if something like that happens and say, okay, well, that number's not on there, so I can't use it. The next number that kind of pops up that is on the unit circle is going maybe backwards is, what about 225? So I know that the sine of 285 could be equal to the sine of 225 plus 60. Those are both on the unit circle. 225 is in the third quadrant and would represent the 5 pi over 4 section. And the 60, obviously, we know is in quadrant 1. So I'm going to use that. So we've got sine of 225 times the cosine of 60. Since this one's plus, we're going to keep it plus, and we're going to switch it and do cosine of 225 times the sine of 60. So again, noting that sine of 225, we know that's bigger than 180 but smaller than 270. So I know it's in quadrant 3. And everything in quadrant 3 is negative. Sine is negative and cosine is negative. The only thing not negative is tangent, but we're not working with that here. So we know it's going to be negative, and I know that at the 225 is the same thing as the pi over 4, so it's going to be negative square root of 2 over 2. And for my cosine of 60, we know that's 1/2. Plus. Over here, I got cosine of 225, so we're going to have another situation of negative square root of 2 over 2. And the sine of 60 is going to be square root of 3 over 2. So working through what we can here, multiplying negative square root of 2 times 1, we get negative square root of 2. And 2 times 2 is 4. Plus, over here, I got negative square root of 2 times square root of 3. I'm going to get negative square root of 6. And 2 times 2 is 4. And it looks like we can bring that together, but I see something nice that's going to happen on this one. So let's just put it together. We know that negative square root of 2 plus negative square root of 6 is really going to become negative square root of 2 minus the square root of 6 over 4. But since they both have a negative, I could factor that negative in front and make it negative square root of 2 plus the square root of 6 over 4. So we would want that answer. Notice that answer looks very similar to the last answer. That's going to happen every single time with these problems. You're going to get a lot of problems that look like square root of 2s and square root of 6s all over 4s. Very normal for them to look the same. So be very cautious with your signs so you don't accidentally make little mistakes. All right. So if we take a look on this next one, it says simplify each of the following expressions using sign, sum, and or different identities. And they've given us some problems that have a little bit more complexity to them because they got some variables in them in the beginning. So for this first one, sine of x plus 2 pi over 3. So we know for our sine formula, we're going to do sine and then cosine. So sine of x times the cosine of 2 pi over 3. And then since it's plus, we're going to put plus, and we switch our signs and do cosine of x times the sine of 2 pi over 3. So working through this, we know that cosine of 2 pi over 3, well, that's going to be in the second quadrant. Cosine is that the x or the y, we know it's the x. So the x would be negative in quadrant 2. So I know this is going to become a negative. And we just got to think at pi over 3, the cosine is 1/2. The x value is 1/2, so it's going to be 1/2. And I skipped that sine over x because there's nothing I can do with that. It's sine over x. There's a variable there. I don't know what to do with it. It's just going to stay 1 sine over x or sine of x. Likewise, this cosine of x, can't do anything with it. It's going to stay cosine of x. Can't change it. Sine of 2 pi over 3, likewise, it's in quadrant 2, but sine is the y value, and in quadrant 2, that's going to be positive, so it's going to be a positive. And 2 pi over 3, well, that's sine at any pi over 3 is square root of 3 over 2, so this is going to be square root of 3 over 2. So what that really means is I could just multiply these numbers by their numerator on top. Technically, we know these are over 1. So we're going to multiply the sine by negative 1 and the cosine by square root of 3, and then the 1s are going to multiply by the 2's on the bottom. So we end up with negative sine of x over 2 plus square root of 3 cosine of x over 2, which we could simplify just one more time and put it all together. So negative sine of x plus square root of 3 cosine of x. For sine of pi halves minus theta. So sine of pi halves minus theta, we're going to work this out using our identity. So sine of pi halves cosine of theta minus cosine of pi halves sine theta. Well, we know cosine at pi over 2 since, sorry, not cosine, sine of pi over 2, since sine is the y value and pi over 2 is going straight up, we know that this equals 1 right here. And the cosine of theta is just a variable, I can't solve it. The cosine at pi halves, again, cosine being the x, since the x going straight up is 0, this ends up being 0 times sine of theta. And 0 times anything is just going to cancel out and is just 0. So this ends up being 1 times cosine minus 0. And 1 times cosine minus 0 is just cosine. All right, down here they've got this one that's already kind of worked out and they want us to put it back together as its simple form. So that's what we're going to do. We can see that in this case we have 75 and 15. And since it's a plus sign here, we know it's an addition problem. So this is going to become sine of 75 plus 15, which is equal to sine of 90. And we know that the sine at 90, being that sine is the y value at 90 degrees going straight up, the y value is positive 1. One last one. Again, we got another sine problem, and this time it's a subtraction problem. So we're going to end up with sine of 290 minus 50, and we get sine of 240. So we note that 240 is going to be in quadrant 3, and it's 60 degrees away from the x-axis. It's 60 degrees bigger than 180. So it's operating off the 60. So we know that we're looking at the 60-degree mark, but in quadrant 3, it's definitely going to be a negative because every sine and cosine in quadrant 3 is negative. And we know that the sine at 60 degrees is radical 3 over 2. So at 240 degrees, it's going to be negative radical 3 over 2. All right, the next section moves us on to learning about the cosine sum and difference identities. Cosine is a little bit different. You can see that for our cosine, when there's a plus, a sum problem, we actually use subtraction in the problem. And when there's a difference problem, when it's minus, we actually use addition inside the problem. So we know that we are going to change the sign in these problems. And you can see that this time it doesn't alternate. It doesn't go sine, cosine, and then cosine, sine. It goes cosine, cosine, sine, sine. So you do 2 cosines and then 2 sines for each one. So using our difference identities, let's go ahead and work through this. So the first one says cosine of pi over 6 plus pi over 2. So we're going to do cosine pi over 6 times cosine pi over 2. Again, because it's cosine, we're doing cosine, cosine. The sign here is plus, so we're going to do the opposite for the sum and difference of cosine. So we're going to put minus. And then we do sine of pi over 6 times sine of pi over 2. So cosine, cosine, sine, sine. So at pi over 6, our cosine is going to be square root of 3 over 2. And at pi over 2, our cosine is going to be 0. The x value is 0 at pi over 2. Our sine at pi over 6 is 1/2, and our sine at pi over 2 is 1. So the 0 up here doesn't really matter. It's going to be 0 times square root of 3 over 2. It just gives us 0. So we end up with negative 1/2 times 1, which is just negative 1/2. All right, in this next one, we've got a difference of cosine. So we got cosine of 120 minus 45. So we're going to write this out same way, cosine, cosine first. So 2 cosines, so cosine of 120 times the cosine of 45. And since this one is subtraction, we're going to change it to addition. And then we put sine of each of them, sine of 120, sine of 45. So the sine of 45 and the cosine of 45 should be pretty easy. We know these are going to be square root of 2 over 2's for both of them. Our tricky one is that 120, but we know that 120 is in quadrant 2, And in quadrant 2, the x value is negative, which means the cosine's negative, but the y value is positive, so our sine would be positive. And 120 is 60 degrees above 180. So since it's 60 degrees above, we know we're looking at pi over 3 or at the 180 spot. So we know that the cosine is going to be 1/2 or negative 1/2, and the sine is going to be square root of 3 over 2. Working this all together, negative 1/2 times square root of 2 over 2. So the negative 1 times the square root of 2 is negative square root of 2. And the 2 times 2 is 4. Plus, and then here I've got square root of 3 times square root of 2, which is square root of 6. And 2 times 2 is 4. So I ultimately end up with negative square root of 2 plus the square root of 6 over 4, which you might rewrite in square root of 6 minus square root of 2 over 4. Either one would technically be correct, but I like to have no negatives in the front. So I just switch the negative and the positive around. All right. For part number 3 of this, now we're looking at the tangent formulas. And the tangent formulas are a little bit more complicated. Notice that there's a fraction now, but there is no sine or cosine. Everything is done as a tangent. And what happens is, since this is plus a plus b, we put a plus on top, but the bottom is the opposite. Over here, since it's minus a minus b, we put a minus on top, and the bottom is a plus. So it's the same sign on top, the opposite on the bottom. And you notice that what they do is they put tangent of a plus b or tangent of a minus b on top. But on the bottom, they're multiplying tangent A and tangent B. The only difference is we've got this 1 minus or this 1 plus in front on the bottom. All right, so taking a look at this, it says find the exact value of tangent of 75 using 2 angles from the unit circle. So I need 2 things that work on the unit circle. Tangent of 75, excuse me. How about 45, right? 45 would work. 45 plus 30. 45 plus 30 would equal 75. So that's what we're going to set up. Since it's plus, the top will be plus, so we'll put tangent of 45. Keep the sign plus tangent of 30. And on the bottom, it's 1 and the opposite sign, so 1 minus in this case, and then we multiply tangent 45 times tangent 30. The nice thing is once you find the tangent 45 and 30, you get to use them twice in this problem, so you don't need to re-find a bunch of things. We know that tangent of 45 is equal to 1, because it's square root of 2 over 2, divided by square root of 2 over 2. And for 30, we end up getting 1 over the square root of 3, which when we rationalize that gives us square root of 3 over 3. In the bottom, I've got 1 minus, and again, tangent of 45 is 1. And my tangent of 30 is square root of 3 over 3. So it looks like there's going to be a little bit of simplifying we can do here. We got 1 plus the square root of 3 over 3 and 1 minus square root of 3 over 3. So we could definitely take these numerators and we could change them into fractions over 3, right? I could put this over 1 and multiply by 3. Put this over 1 and multiply by 3. So what I know is this top one becomes 3 over 3 plus square root of 3 over 3. So we're going to have 3 plus the square root of 3 over 3, all over, in the bottom, 3 minus the square root of 3, all over 3. And when we do keep change flip, we would take this bottom one and flip it up top to change it to multiplication, and it becomes 3 times 3 minus the square root of 3. So these 3's would cancel here, and we would end up with 3 plus the square root of 3 over 3 minus the square root of 3. For the next one, it says find the exact value of tangent of 165 using 2 angles from the unit circle that add up to make 165. I think this one's another one that might be dealing with 45. Looks like maybe we could use, maybe not 45. Hold on. Well, we could use 135, right? 135 is in quadrant 2 plus 30. So 135 plus 30. So when I set this up, I'm going to have tangent of 135. Keep the same sign plus tangent of 30. All over 1 opposite sign, tangent 135 times tangent 30. That's a times sign, not a minus. All right, so tangent of 135 is going to be one of the ones again because you got square root of 2 and square root of 2 over 2 for both of the x and the y. But it's in the second quadrant. So in the second quadrant, we know that tangent is negative, so it's -1. The tangent of 30 is just like that last one. When we rationalize it, you get 1 over the square root of 3, but rationalizing you get square root of 3 over 3. And in that denominator, we have 1 minus tangent of 135, which is still negative 1. And tangent of, which is square root of 3 over 3. So for the top, we get negative 1 plus the square root of 3 over 3. And on the bottom, we have positive 1 plus the square root of 3 over 3. Doing our rationalizing, put this over 1 and over 1 and multiply by 3. And we're going to end up with 3 plus the square root of 3 over 3. Sorry, it's a negative. Sorry, there's a negative in front here. So it's negative square root of 3 plus the square root of 3 over 3. Hold on, I did that completely wrong. What am I doing? Okay, try this again. When you put it together, you get 3 over 3 plus 3, negative 3 over 3. Put the negative in front here. Negative 3 over 3. How have I confused myself this much? Oh, yeah, I circled the negative, and that's why I'm confused. I'm sorry. Okay, I circled this negative, noting it's negative, right? So it's negative 3 over 3 plus the square root of 3 over 3. So it's negative 3 plus the square root of 3 over 3. And in the bottom, it's 3 over 3 plus the square root of 3 over 3. So it's 3 plus the square root of 3 over 3. Again, when we do keep, change, flip, we would multiply this by its reciprocal. So we do 3 and 3 plus the square root of 3 when we move this up. So we know that these 3's here are going to cancel. And we get negative 3 square roots of 3. Nope, there's a plus there. Negative 3 plus the square root of 3 divided by 3 plus the square root of 3. That would be our final answer. All right, bringing up the end of this, says, suppose that sine of theta is 3/5, sine of alpha is 5/13. Additionally, tangent is greater than 0. Tangent of alpha is less than 0. Draw angles theta and alpha, labeling the reference triangles, and find the value of sine of theta plus alpha, cosine of alpha minus theta, and tangent of theta minus alpha. So the first thing we need to do is we need to draw our triangles, right? The first one says that we have sine of theta is positive 3/5. So sine can only be positive in quadrant 1 and quadrant 2. But it said that tangent's also positive right here. Tangent of theta is also positive. So the only way for tangent to be positive and sine to be positive is it has to be in quadrant 1. So I'm going to draw a right triangle in quadrant 1. For my second one, it said that sine of alpha is positive. So yet again, since sine is positive, we know it's in quadrant 1 or 2. But it said tangent is negative. So for tangent to be negative, it has to be in quadrant 2. That is the only way we're going to get a positive sine and a negative tangent. So when I set this up, sine is 3 over 5 for this first one, right? 3 over 5. So this means that the opposite over the hypotenuse is 3 over 5. So the opposite of my little theta, which goes here, the opposite is the 3 and the hypotenuse is 5. And for the other one, sine is 5 over 13. Again, opposite over hypotenuse, with my theta being here at the origin. The opposite is 5 and the hypotenuse is 13. So we're going to do a Pythagorean theorem to find this missing side. I want to know what this side is over here, and I want to know what this side is over here. So we're going to do some Pythagorean theorem. So for the first one, I've got 3 squared plus x squared equals 5 squared. 5 has to be the hypotenuse. So I get 9 plus x squared equals 25. X squared would equal 16, so x equals 4. Over in this other one, we've got 5 squared plus x squared equals 13 squared. So we get 25 plus x squared equals 169. When I subtract 25 from both sides, I get x squared equals 144. So x equals 12. So the question says, what is the sine of theta plus alpha, cosine of alpha minus theta, and then tangent of theta minus alpha? So let's start with this first one, the sine of theta plus alpha. We just talked about this formula, that what we do for this formula is you do sine of theta times cosine of alpha, keep the sine, and do the opposite, cosine of theta, sine of alpha. So what I know is sine of theta, since sine is opposite over hypotenuse, I already knew the sign though. They gave it to me in the beginning, was 3 over 5. So it's going to be 3 over 5. Cosine of alpha is going to be adjacent over hypotenuse. The adjacent in alpha is 12 and the hypotenuse is 13, so it's going to be 12 over 13. Plus, cosine of theta adjacent over hypotenuse is going to be 4 over 5. And the sine of alpha being opposite over hypotenuse is going to be 5 over 13. Multiplying this together, 3 times 12 is 36. And 5 times 13 is 65. Plus 4 times 5 is 20. 5 times 13, 65. And when I put that together, I get 56 over 65, which we know would simplify to 56. Oh, I lied. That doesn't simplify. Yeah, that would be it. That is our answer. All right. So the rest of this is just some good practice for you to try out. We'll go over that in class if you get stuck.